Hello everyone. Whoops. I wasn't in too close. Hello everyone. You ready to start?
Yes, Chris.
I can see one person in the background. Okay. What I'm going to do today, I can go through a droning on lecture about the theory of this or the theory of that. I'm going to show a couple of presentations that are reporting presentations for progress and payments for a design, tender construct contract, civil works,
Chris,
and
just
also for a design build contract for a track work and third rail.
Chris, just a second. Hello,
Yes.
Chris. Could you just move that window, the Skype window, from the screen? It's coming on top of the presentation. Yeah.
Okay.
Yeah.
Okay. Well, I can't see you now, but you can see the picture.
Yeah, we can see the PowerPoint.
Okay. Start yelling and shouting if you you lose me.
No problem.
So what we will do is I'll go through that, and that will give you some idea of what the project management is about and sort of the things that get focused upon. And hopefully we can get through this in about an hour. There's hundreds of slides here, but I will skip a lot of those. So let's get started. Now, project management, of course, is getting from one place to another past a whole series of obstacles. But my point today is a lot of reporting has to be done on a regular basis, both for record to keep and also to get the support and make things happen when you need things to happen. So today I'm going to talk about complex projects, infrastructure rail projects for the reporting and monitoring. I'm just going to focus today on the left side of the screen there. Just the basic reporting and monitoring that really needs to be done. Today there are a lot of advanced technologies using computers and visualization, building information systems and all these very, very clever things. But today we'll focus on how perhaps to report a fairly complex job using fairly basic tools, Primavera, Excel spreadsheets, and PowerPoints. That tends to be very common throughout Asia, India, and the example I'll be drawing upon is for a project in Bangkok, an elevated rail system. So that's the project. It's the Green Line project in Bangkok, and it's civil works. And civil works cover a range of things. In this case, they cover the viaducts, that's the elevated structure, elevated stations and the depot, and it's a design, tender, construct contract. If you can remember in all the last talk we had on, I explained what design, tender, and construct is for the employer. That's the authority, essentially produces those documents through their consultants for the contractor to go away and build the job. Typically at a monthly meeting and in monthly reports, you have an agenda that covers the financial aspects, progress, interfacing, recovery for delays. Give me 2 seconds while I close the door. They seem to be having a party outside. Okay, I'm back again. As I said, I can't see you, so I don't know whether you've all gone away or not.
We're here, Chris.
Yeah, good. Okay, so it's a typical meeting with a format there with control and minutes, the last meeting and those sort of things. Usually the first thing we focus on is the financial aspects of the project. That relates to payments, provisional sums and variation orders. Now, if anybody wants to ask a question, I suggest they put up their hand and relay it to Binoy, who can then carry it forward to me.
Sure, Chris.
These little blue boxes I've put on top of the slides are just some comments I've got there. But you can see it's a spreadsheet type of format that indicates what we call interim payment applications, usually every month. So you've got month 1 through to 9, 10, 11, 12, however long you go. The interesting thing to note, if you can you see my pointer?
Yes, Chris.
Okay, is advance payments are usually paid at the beginning of the job, maybe about 10%, so the contractor's got some working capital. Then that's progressively recovered, 5% each payment. There is retention taken from each payment so that the client has a guarantee, a pocket full of money just in case things go wrong. The retention can be not taken out if there's a bank guarantee. So there are all of these complex little bits and pieces that need to be adjusted to what's essentially a fairly simple spreadsheet at the end of the day. And that usually follows a disbursement plan on an annual basis for those payments. Other adjustments are made, say for escalation, if inflation sets in above a certain level, perhaps if it's more than 4%, there's a formula that in this case has introduced additional payments due to escalation. Now, these things are summarised for each month. The variations are also looked at, and a variation order is a signed amendment to the contract, and it may increase or decrease the scope, the time, or the cost. So in our column up the side here, we have a list of signed variation orders. The red is actually a saving, and the blue is actually a cost increase. Whether that's logical or not, I'm not sure. So we need to report on those because you're working within an overall budget for the project. It's usually a set amount at the beginning, which is based on the original bill of quantities, and then a contingency and other provisional sums are applied to the top of that. Now, variations, to get that signed variation order can sometimes take 6 months, 12 months, because government authorities in particular are very slow. Those people are very reluctant to sign their names to things unless they're totally covered. So generally, the contract often allows for an instruction to be given by the employer's representative, project management consultant, or the like, on behalf of the employer, to instruct the contractor to start that work, to start to plan for it, to start to work out how much it's going to cost. And in fact, the contractor is usually obliged to do that. Then if there's any dispute at the end over the final price and those sort of elements for the final variation to be signed, it would move into a claim or a variation. So that process is done to help move the project along. So we have instructed items, which the contractor has been told, okay, you need to do this work. We've got a pretty good idea of the cost, and we put those in so that we can keep a track of what the overall project is going to be, whether it's going to be within the overall budget. Because as soon as it gets outside the budget on a government job, you have to go back to government and get more money. And that's one of the biggest difficulties working with government clients, is when you get that final top of the budget, there's no more money to pay unless they get approval from whoever's funding them, either the government or one of their multilateral or bilateral funding agencies.
Chris, just one question.
Yes.
The payment schedule, are they as per the contract, or will there be a different schedule as per the completion of the works?
Okay. As per the original contract, there will be a payment schedule that's generally worked out because a program is submitted by the contractor and a price bill of quantities.
Okay.
That's then used to develop annual disbursement schedules so that the authority or the employer knows how much money they will need in a given year. Now, a couple of things can happen. You can get variation orders, which could increase or decrease the price. And when they're approved, then you have to readjust your disbursement schedule. And then you may get a case where the contractor is actually moving quicker than he should be moving against his program. And in fact, in the next slide when I talk about next presentation for the track work, that actually happened, and the contractor had a lot of his rails on site, but didn't really need them and was trying to get extra money. And the client actually resisted that and said, no, we just followed the disbursement schedule. It's your fault for getting everything there too early. So unless the client wants to accelerate the works, to pay that accelerated money, then you have to tend to be within the overall disbursement schedule, because that's the funds that are approved to basically pay the contractor in any given year.
Okay.
So when we look at the progress of the work, how do you measure progress? Now, if you stop and think about it, you've got a whole bunch of diverse items. You've got apples and oranges, and if you've got 2 apples and 1 orange, how do you add that together as progress? Now, I think if you can remember back to my last presentation, the way that you can add those together is by the value of those items. So 2 apples cost so many rupees, and 1 orange costs so many rupees, and so that's the value of the work we've done out of perhaps the overall requirement for 100 apples and 50 oranges. That's how progress is measured in terms of cost. It is also measured at an individual basis. We've done 3 apples out of 10 apples, but for putting it all together in what we call an S-curve, where we can take all the items of work. You can't see these very clearly at the moment, but the next slide will show those. They include things as general requirements, mainline stations, all the cost of those elements. So against their programs, which are going through here, we add costs and completion, and can actually generate a plan curve for what's essentially the value of the work at that specific time. And then the contract is actually measured against that. So in this case, you can see a little red curve coming up here. That's where we are at the point of this presentation, and the contractor believes they're about 2.57% ahead of their schedule. So that is how all of that is measured in terms of what is called earned value of the cost of the work. This shows you in a little bit more detail these items, and they're called bills because they're in a bill of quantity. So for my project, or this project here, which is the civil works, it's actually fairly simple. It breaks up into some fairly major simple components, general requirements. They're all the sort of special little things that the contractor has to do. And you can see they're at about 5% of the total value of the contract. The mainline and the elevated structures, they're the major component, and they're at about 33.8%. Then you look at all the stations down here, about 3-4% value of work for each station. We have an interesting case in Thailand where we have a depot and an operational control center, which is actually 23% of the cost. If you go down and look at Hyderabad's depot, it will be nowhere near that percentage of cost. But the strange situation in Thailand is that they build all their depots on an elevated platform. It's got piles and piers and all those elements, and that's why that's actually so expensive in Thailand. It's another item for provisional sums, which are items that you really don't know the cost about. You make an overall allowance for those so that when the contractor bids, he knows what they're liable to be, and then they are negotiated during the term of the contract for certain amounts of work. So that's how that's all built up, and so you have percentages and they're weighted, and then you can weight the actual against the plan and get a sense of the amount of work that's been done and its value. This is an interesting one. This is an item that's in there called the Electrical Authority's electrical works. That was originally in the provisional sum because nobody really had much of to be. If you go back to the last slide, it's actually about 6% of the value of the work. So that's a lot of manholes and drainage and manholes and cabling that needs to be provided for the Electrical Authority to provide a permanent power supply in and around the stations and the viaducts and the piers. An expensive item, and it highlights on these sort of projects how important the utilities are and the cost impacts that they have. So that just gives you some idea of the physical nature and the size of these things that have to be built to accommodate, in this case, permanent electrical works in and around the project. So we've just got a few slides that show those sort of things. Manholes and cable trenches and trains. Yeah, what tends to be fairly common in Thailand, PowerPoints used. And that's not such a bad thing in a lot of ways, and it's interesting for those who want to get a feel for the picture. So over on this side, piling works and pile caps are being finished. In fact, about this time they'd all been finished for the project, and columns were coming up out of the ground, and you can see those. This is another better picture of the columns coming up out of the ground on a big, massive pile cap that's cast there on top of barrack piles, big, large 3 metre by 1 metre barrack piles under station sets of floors going down 20, 30 metres. That's interesting because that represents a large percentage of the cost, and it's a feature of Bangkok, whereas if you're in Hyderabad, foundations are much simpler, and the relative cost of the substructure underground is a lot less. Well, we have that work, and you can see stations coming up, stations which have a platform level up the top here and a concourse level at the bottom there. So all of this tends to be reported on so that the authority and everybody has a good feel whether you are on a project. It also means if there's a problem area, you can stop and talk about it and think about it in a little bit more detail. Segment erection, I'll just go and showing you the sort of things that are involved in an elevated project. Up the top here, you can see these elements along here. That's a parapet that's going along the side of the viaduct that's installed, and they're items that are measured on a linear basis, precast segments. Here we have some work for pump houses and generator rooms with direct grade underneath stations. So these are the sort of things that are involved in the job. Here we can see a nice long good stretch of viaduct. And here we can see a gantry effectively coming around the curve as it pivots ready and to put its segments in each section. Interestingly enough, if you've got enough gantries, that doesn't tend to be the thing that holds up a project because you can do a span perhaps in about 4 or 5 days. What does hold it up is if, say, this pier can't be constructed because of utilities or something like that, or land acquisition, and you don't have a good run of your project. So they're the sort of things you're looking at and perhaps discussing with your progress meetings. Here we have a viaduct that's going to be going across an expressway. Here you can see it's actually very high. And here are the other pile caps up here ready for the gantry to run along, come along to here, up to perhaps a pier that's in between an elevated roadway. These tend to be one of the 3 or 4 sort of tricky areas on a project where you can get delays and have to be watched carefully. More pile cap work, platform slab work, more work on the concrete platform slab and concourse and the like. So let's just get through some of these. They do tend to overdo this a little bit in their presentations. I think on the basis of they can show a photo that proves that it's been done. Here, this is interesting if you're trying to understand how a viaduct is constructed. The pier head's built, and then a segment is installed on top of that pier head, and then the viaduct comes along. Basically, not viaduct, the gantry comes along, lifts up segments, and they get installed in between those segments on the pier caps, and then they're tensioned together by large cables and basically held in place. So it's quite interesting to watch. So let's move on through this. Big slide. Okay, here we are now up on top of the viaduct. Interestingly, you can see these are the parapets that have been positioned in place and braced. So they're all concreted in, and the reinforcement is stitched together with reinforcement on the viaduct deck. So this is the viaduct deck you're looking at. You can see down the middle points for drainage. And this is where the track work will go. Now, what you can see from a lot of these elements, they can be measured in terms of linear meters, cubic meters of concrete, all of these elements, and that's how item rates are established for payment. So if you've done so much parapet, or whatever it might be on a linear basis in that month, you can put in a payment application based on a rate per meter that covers that element. Bearing in mind this is a design, tender, construct, remeasurement contract. More works here, girders and the like that need to be filling in places. So this is the parapet. Oops, I'll go back just for that. I think it's about $200 per meter in Bangkok, and that's what it costs, and that's how it's paid for. Starting to get steel structure. Now we're approaching down into a depot area, very large depot site, as I said before. Casting yard where there are segments. So every time a segment's cast, that's an item, it has an item rate against it. The contractor can essentially bill the client for that. Other precast items, the parapets we saw before, cable troughs that go in next to the parapets to run cables, and a lot of precasting work as much as possible helps on the project. In the stations and at some locations you need girders in between the cross beams. Of course, in the station there's a lot of steel work on the roof and the like. This is being fabricated either in a contractor's yard, or in our case, it's actually being fabricated on that very large depot slab, I said. On many projects, that's that grade, it will be a muddy quad wire. But here we've got a good working area, and the contractor takes good advantage of that. We have an operational control building. You can see the progress sort of elements that are reported there. This is this very large depot slab that I'm talking about here. 100,000 square meters. On columns, about 4.5 meters high. On piles, about 40 meters deep. Very expensive.
Chris,
the workshop. Yes?
Is there any reason why they've actually put it up on piles?
Yes. This is a, try and go back. It looks all very nice because it has a couple of meters fill. But if we go right down the end here, we hit mangrove swamps, about 500 meters. Then we hit the delta floodplain of the Chao Phraya River. So once every 50 years, this will be full of water. There are retention ponds and the like underneath. The other way of doing it would have been to build the whole area up to a satisfactory floodplain height with dirt and earth. It may have been cheaper. It would have taken longer because you've got to compact the earth and the soil and those elements. But I think their designs are not necessarily that smart, because if you're going to do all of this, you don't necessarily need to do it all. You do it smart and you build the elevated area exactly where you need it, and leave a lot more empty spaces, if you like.
Okay.
Just going through some of this. And here we have a test track next to the depot. And here, in fact, did some value engineering savings because they hadn't allowed in the bill of quantities enough for all of this earthworks underneath. So there was going to be a major cost increase. So we got rid of a lot of the slab here, and the test track just became a test track, somewhat separate from the depot platform, walkway access down here. But we got rid of a lot of concrete and piles and piers in this area to save money for somebody else's mistake. Earthworks, retaining walls. What we do look at is what's going to happen in the next 3 months, and obviously very important. And here you can look at specific details. This would be the main line. Here I'm talking about viaducts. So you can see the specific elements, whether they're a pile cap, a parapet or a segment, how much has been done, how much has been done as planned, how much is going to be done in the next 3 months. We also compare it against revised programs that have been introduced due to variations. And so you can have a quick look down here, and you can see most of the substantial viaduct structures are complete, and they're doing a lot of their work on the parapets and some of the segments, and you can see what's coming up in the near future. So here you can actually measure apples for apples. So you're measuring pile caps for pile caps to give yourself a percentage. You're measuring parapet production, each parapet, how many of those, and so you can get a percentage there against those elements. But you also know what the quantities are and the costs are, so you can put those in the original spreadsheets. You do the same for stations, you do the same for depots and the like. Here, because the primary works are civil works, they're showing all the civil elements. Later on, they will show a lot more of the E&M building service elements and the architectural finishes when all the civil works are essentially complete for reporting. Again, for the depot, rolling programs. Interfacing works are very important. In the contract, quite often key dates or interface dates are included for contractor compliance, and he has damages against those. So there are interesting items that he has to finish a certain amount of certain stations to be able to hand over to a different contractor or a C3 contractor who does the mechanical and electrical work. If he doesn't achieve those key dates, he's in trouble and pays damages and the like. And there are also interface dates and the like that are used to basically control the contractors between contracts. We also look at the problems, instructions and resolutions because we're trying to resolve those. Now, in our case, we didn't really have terribly many. The first one up there is due to an entrance and complaints by local residents. The other one was about an existing very large water pipe that somebody found and was obstructing another entrance. And in fact, they're probably two of the main problem areas you get in an MRTS. That's entrances and the public complaints. People don't want entrances in front of their property, and existing utilities, ones that you find, and an entrance has got to go on top of them, and you suddenly find that's where a pier has to be built. The third area is probably the railway crossings and highway crossings, because you've got to get approval from the railways or the highways department, and that always drags on. We also talk about recovering from delays. Unfortunately, in this slide, and it just happens to be coincidence, that month there were no delays. Everything was in the critical path. But if we looked at it the previous months, we would have had some items 200 days in delay against the critical path. Now, what actually happened was that there were a couple of major variation orders issued, one to do some additional work with stations and one to do those electrical permanent works that I talked about at the beginning. Those variations were both a cost increase and a time increase, one for 210 days, one for 150 days, and then the contractor was able to jiggle around and recover all of his own delays within the employer's extended time. And so this is essentially due to a client being too slow in approving things and the like, and that gives the contractor a lot of what I call wiggle room to recover his own mistakes and delays. I won't go into safety here, but there's usually a presentation on safety showing what's happened and what hasn't happened, usually a presentation on environment. And in our case, it's not like the US or the UK where they're worrying about fauna and rare toads and all this sort of thing. It's more dirt and dust and rubbish and those sort of things, and how high is the barrier, is it in place, have they disturbed the footpath and those sort of things. But still quite a lot of reasonably good monitoring. We also report on the QA and QC, and this is whether there's non-conformances and the response to quality management procedures. Our job, in fact, has a lot of non-conformance reports that are issued. It's because there's a contractor-driven variation order where they wanted to do the design to be more efficient and reduce costs, and they found that the design is taking them a lot longer than they require. So a lot of their working drawings have only been approved at a code 2, which has comments. And to allow them to continue and move forward, they then do their construction work on those marked up code 2 commented drawings, and their non-conformances can't be closed until the as-built drawings close them off. So we have a peculiar little thing there of many non-conformance reports, more than you would normally expect. But they're the sort of things we track. We do auditing at suppliers, do a lot of PRCR on our job, which is telling people what's happening to the roadways, telling them when U-turns will be closed, going out and meeting the community, a lot of advertising, a lot of shaking hands, a lot of money in budget is actually allowed for that to feed out to the local community for a variety of activities, basically to keep them happy. And I don't really see much like that in India, but as I said, there's quite a big PRCR budget, which can range from distributing bottles of water, firefighting, training for firefighting for their own houses and things like that. So very much a big activity. Then we tend to wrap up with comments from the MRPA and the GDSC, who's actually the employees representative, and the project management consultant. So that was for a civil job. What I'm going to do at the next slide is just run through and show you how it slightly differs a little bit for a design-build civil contract. So let's see if we can find that. Let's get rid of this one. So any questions? Okay.
Chris?
Yes.
Just a query here. What is the approximate cost for the OETS work per kilometer for a MRT project?
For the what work?
Overhead electrification.
Well, for this project, nothing. And I'll explain now in about 2 minutes, because we don't have overhead electrification.
Okay. But generally, what is the approximate cost?
Oh, what would be the cost? I always argue that if a mass transit system is 100%, the civil works tend to be about half of that.
Yeah.
The rolling stock tends to be a quarter. Each of the primary systems, such as train control and power supply, tend to be about 4 or 5%, and then the overhead line maybe 2 or 3%, I think, about of that order. Relatively. But overhead line really isn't very common in mass transit systems, except for in India.
Okay.
Tends to be third rail, and I'll show you something interesting here on that in a moment. So this was for, this is for the track work contract. This is a design build contract. where the contractor does the detailed design. So the difference from the last contract with the detailed design was done by the employer. In this case, it's for the system-wide track work along the main line in the depot and for the third rail. The third rail provides the electricity, not an overhead line. Okay, so we move on down a little bit. It's the same sort of things and payment schedules, so I'll skip across that where we are. Same sort of things in advance payments and retentions. Same sort of thing on variations. So the observation here is we tend to get less variation orders, particularly when in Asia, the design tend to construct in Thailand and in India, design consultants are very low standard quite often, and there are a lot of errors, and so that generates a lot of the variations we had in the civil contract. Here the design is being done by the contractors who are much better at getting good consultants to do the work. So less variations. And this was a major variation where an additional pocket track was added. It had actually been omitted and forgotten by the civil contractors. We put it in the civil contract. Of course, we needed some track work in the track work contract. Now, this one sort of partly answers your question. These are the four elements that comprise the costs of this contract. Now, we have the preliminaries and general requirements, which are 10%. We have design, which is about 3.5%. We have the actual track work, turnouts, and all of those things in the main line and the depot, which is 60%. And then we have the conductor or third rail, which now I'm guessing it must be about the sort of equivalent cost, perhaps of the overhead line and the like, perhaps a little bit more. It's 25% of the cost. And this contract is about 2 billion baht. Now, baht, we get 34 to the dollar compared to a rupee, which is, what is it, 62 to the dollar or something?
Yes, 64.
So if somebody wants to do a conversion of 2 billion baht, multiplying by 60 over 34 or the other way around, and then take 25% of it, that's how much our third rail costs. Now, we also, don't forget, have a M&E contract with power supply, which includes traction substations and a lot of the power cables. So we're not really comparing that exactly with your overhead line. But that gives you an indication. Now, what have we got here? Again, we've got the S-curve. Does anybody think that looks like an S-curve? Perhaps it did originally, which was this blue line. And here the actual progress was well in advance of that, in part because they got some of their design deliverables out the door very quickly, and in part because they got all their rails shipped in one big batch from Japan rather than 3 shiploads, because that was the economic way of doing it. But the client refused early payment on this because they didn't want to pay the extra interest for stuff sitting around. And in fact, it was argued for about 6 months until they got back onto the curve. So that's the scenario you've got there, the sort of things that were shown. Again, those 4 cost centers, if you remember, this is the preliminaries and all of that work. So this is vehicles, access, guarantees, bonds, all of those sort of things that are done. They support the job, and that had a weighting, what was it, 10% of the overall cost. And then the individual items are weighted in the contractor's bid, so we know how much they are. Then an estimate is made of the actual progress of those various elements. And so in some cases, guarantees and bonds will be right up at 97%, or pretty close to exactly what they should have done. Other elements are almost pro-rata to to where they are on the monthly progress of the job, such as vehicles and those sort of elements. Cost Centre 2, now this is another very interesting one because this doesn't exist in the previous presentation. This is the design by the contractor, about 3.5% of the project cost, multiple design phases, preliminary design, detailed design, installation drawings, working drawings, final design that go through the whole project, a whole list of various deliverables under those, many multiple design submissions that are looked at for compliance with the general requirements by the employer's representative, and then when those specific deliverables are made, they are all added up against the percentages to work out how much the contractor has earned. Then you look at something, the third cost centre is the track work itself. Now, the track work has many items, as you can imagine. It's not just a rail, it's fastenings and turnouts and bits and pieces and spares and tools. And some of those materials will come from offshore and some will come from onshore. And they're all quantified and given a weighting and a value. So when they're on site and they've been inspected and signed off, they can be paid for. Similarly, when you've got installation, various activities that range from getting the site ready to actually installing the track itself, which in turn has its own elements of work, from the survey to welding and to putting sleepers in and concreting and inspecting and testing. Spreadsheet can develop all of these costs. I think if you could imagine that in your mind, you can break something up into the elements, you can work out generally what a cost it's got against it, and you can produce an Excel spreadsheet that basically gives you that total figure. Then you can weight the progress against it. If you've done half of the track, you've got 50%, that's 50% of the cost. If you've got half of the rails, similarly that's 50% of the rails cost. So that's how that all has to be tracked and kept an eye on for payments and the like. So then of course you've got the installation of the track work, and similarly we have the third rail, which is, I think you're all familiar with what a third rail is. It basically mounts on a bracket that mounts off of the track slab or a plinth slab or off of the whatever the track's mounted on. It basically is a composite of aluminium and another steel material, and it basically carries the electricity which is collected from a sort of a flexible shoe type affair on the train itself. So that's the power supply to the vehicles.
Chris, in this
Yes.
case, the third rail activities, is the package given to the power supply vendor, or is it for the civil contractor?
Third rail is almost universally given to a track work contractor.
Okay.
Because it's a physical thing. It's a physical rail, looks a bit like a rail, it's mounted, it's installed all where the rail is installed. It's on brackets on the track slab, which is part of the track work contractors. So they provide all of that. Now there are interfacing issues. There are holes that need to be drilled in it for mounting connections for the actual power supply, the electricity when it's coming out of a standard electrical cable from a traction substation or wherever. There are those sort of interfaces. But to be honest, they're relatively minor. And in fact, the power supply contractor, when he's on board, he builds his traction substations, he lays his electrical cable, he may have to drill a few holes to get it through viaducts if they weren't put there where they should have been. But then he just connects basically up where he wants to for his power supply and his sectioning, and for straight current control. and those sort of things, and he just uses the third rail, which is physically there to be used.
Okay.
Again, interfacing is important, and I'm going to talk about interface management in some slides later, where it's all the detailed interfaces between this system and that system, civil and rail systems. Here, a lot of the interfacing is a physical interface, in this case between our trackwork contractor, who we call C2, and our civil contractor who built that big, massive depot slab, and they're still building it, who we call C1. Now, you can't always wait for one contractor to finish the other, so there are handed over areas of work from the civil contractor to the trackwork contractor. So the trackwork contractor becomes responsible for a zone. We've got zones down here at certain dates. He has that. He can do his work in those zones. And that's quite important, because if you remember, I showed you, I think in both contracts, key dates for certain things. And I just got a claim on my desk today because C2 contractor, the trackwork contractor, wasn't able to get access because the C1 contractor hadn't finished. And so C2 was muttering on about how this will cause delays, blah, 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 blah. So that's something we've got to manage and work out whether we can overcome that. Okay, then I've just said that in the blue note. So it's a physical interface and an access interface, because as you can imagine, the trackwork contractor tends to move in one direction and he needs access for his vehicles and all of these elements. Now, I will say this trackwork is a really, really funny contract. What we're looking at here is the depot, and it's on a nice, beautiful slab, as you saw before. And the original design was to have ballasted track. Ballast is all those little rocks when the rails fit on the rocks. And essentially, due to probably corruption and other things, the contract was turned into a track slab, as you can see in here, with embedded sleepers, more value, more money slushing around, and things like that. Our C1 design was designed for ballast. C2 came in as track slab. Well, not our fault, because we had nothing to do with the tendering. Lights, slabs, and the tracks, and all of these sorts of things. So an interfacing issue before we'd even started. Now we move into the main line, and the contractors just started to work in the main line. As you saw from some of the civil pictures, all the main line isn't finished, but a lot of it is. And because this contractor, this trackwork contractor, is doing his work on basically a one-front mechanized basis, where he builds up a framework, a certain length of track, he's fastening his sleepers and things. He just moves in one direction from one point, rather than a much more manual system where you have gangs of workers working on 3, 4, 5, 6 fronts. So in this case, it's very important that we have a front available for our trackwork contractor to have a clean run down the civil viaduct. So he's obviously just started in this area with a bit of brickwork from one station onwards. We have little minor interfacing issues in relation to things like insulated rail joints, power feed from the power supply, work with M&E works. And again, the thing that happens in Thailand, time and time again, they award civil contracts, they fall around trying to work out whether the M&E should be PP and that and the other. The civil works, the track work, is almost finished before the M&E even starts. Our M&E hasn't been awarded, hasn't even been tendered, so we end up with a lot of fluffy interface areas that will cause us headaches later. So I'll talk about that a little bit more when I talk about interfacing. The other important interface is with the operator. Now, the line we're talking about is an extension line. So there's an existing operator that operates the existing Bangkok transit system. And again, they've been going around and around in circles. Whether you have two separate operators, MRTA operates and BMA operates, whether they have one line and all this. And I think the government's finally had enough of it. And being a strong military government has actually made a decision. And I think they will probably give all the operations to the existing operator, so the MRTA loses it, which is actually a good thing as long as my job continues with the owner for the other line. Again, design and engineering, a long time. If you're involved in looking at the planning for rail systems, contracts, and that simple thing of preliminary design that happens submitted reviewed in this month, detailed design later. It has many components, many separate submissions, all stretching out over a long period of time, and all needing review by the again, moving like reported, all the status of procurements reported. Here an example shows the concrete sleepers, estimated quantity, how many have been ordered, how many has been complete. All the status of procurement needs to be followed. Instruction needs to be followed. Because here we're not measuring the work based on the work that was actually built during a month. We're measuring it, looking at what's actually being done as an overall. So here we look at the depot. This is representative of the 6 main activities going through from survey, welding, the rail, the concreting and inspection and testing. And you can see the bits here that I just plan track all the stages of work. So yeah, that can be shown for all the areas, and automatically that's quite useful. I think. Of course, if you're using very grand and loading it all against criminal error, that will tell you what's happening. Sometimes that's easier said than done. Just another bit of detail showing you what's been done, what hasn't been done. I deleted a lot of those just to show you some. As I said, you wouldn't normally see this in a depot. You wouldn't on a viaduct. You would probably see it in a tunnel. Way too expensive. 50 to 100% more expensive than simple little plinths for the track work. Now, it's got little L-shaped plinths just to mount this track work on. And in reality, that's all you need on the viaduct and for the ballast here. And all this work's going on, which probably shouldn't be going on in the work and stabling areas. But they've got a more mechanised approach for doing 25 metres, getting everything set up, getting all the gauging set up, all really nicely done, all nicely automatically welded, and then they move on and do the next section. The only disadvantage of that is you're just moving in section by sections rather than doing it manually. Here we go. Between 2 stations, so the work that they've actually done again with this colour-coded system. Here we are now up on the viaduct. This is the parapet that you saw before. Here's the cable tray trench that you saw in the precast yard, if you remember. If you go out to Hyderabad, that's all on racks that are actually exposed on the side of the parapet. Here we don't have any elevated overhead line, so it does actually look a lot neater from the outside. And even though there's a lot of power lines in Bangkok that are around on the outside. The other observation I make, if if you look at the Hyderabad Metro, they seem to have a lot more overhead line posts. The spacing of those posts is very, very close. There is one line in the city in Bangkok, which is the airport rail line, which is a much faster line, the maximum speed of 185 kilometres. So overhead line makes sense. But there, the spacing of the posts is about 60 or 70 metres compared to about 30 metres in Hyderabad. And I think Hyderabad's a little bit of an eyesore as far as their overhead line goes. You can discuss that with me later if you want. Okay, the work going on, all nicely set out. If you see the way the work's done in India, manually with people actually physically hauling their rail into place and then welding it and like it. So a mechanised approach is better. As I said, milestones, these tend to be much more a completion of stages of work rather than available handover, which the C1 contract, civil contract, had. It was responsible for handing over areas of the depot by a date. It was responsible for handing over signalling rooms, comms rooms, etc. to the M&E works by a date, because this tends to be much more 100% or 50% clear, complete. So very much more on a milestone basis here in interface states. They report on safety and health again. This is typical safety accidents you've had or haven't had. In this case, there were no accidents with the track work at all to date. They have safety talks and like to show what they've done. They have safety procedures and the like, and so working at height and lifting, still quite an area that needs hazard assessment with each individual element of the work. So it's the civil works. Working at night, albeit they're working now up on the viaduct, they have to get their vehicles up on the viaduct, they have to get their rails up on, and so they do work at night, the same as the civil contractor does work at night, where the road has to be petitioned off and cars diverted and the like. Environmental activities, they don't make as much mess as the civil works, of course, and they have it a little bit easier to keep their site clean, but again, they're monitored and have to do a whole lot of environmental work and every month rather, both at night and during the daytime. Much less non-conformance, and so their quality submissions are the status of their submissions and whether they're being reviewed in 14 days or not. Very limited number of non-conformances here compared to those ones I identified for the civil works, both in part due to the nature of the work and because of this funny issue with the contractor on the civil works is working off with drawings that are still code 2, which are marked cut drawings rather than final drawings. A lot of testing they have to do though for a track work, dimensional tests, strength tests, shear keys being pulled out. I think I deleted a lot of photos showing examples, but that needs to be done. And similarly, that would finish there. So that's the basis of basically reporting. I did have another couple of presentations which related to payments, where again they show the same sort of thing, but they have a lot of supporting evidence to prove that they've done a certain quantity of work or they're that stage of work. In the case of the design build, they have receipts for the material that's arrived and pictures of the material that's arrived, and all of these things so they can get paid on a monthly basis. So we've essentially used up the hour. Are there any questions from anybody? Are you still there?
Yeah, Chris, is the format similar for the other packages also, apart from civil and track?
Okay, the track work will be very similar to the rail systems. The rail systems will have the similar components of work, general requirements. They will have their design submissions as a primary package. They will have their installation. They will have their, I think their testing and commissioning and integrated testing and commissioning will come out as a larger component. And the track work, it gets hidden in the installation, but train control and power supply all need their integrated testing, so that will come out as a key component. And also the thing, it may not appear in Thailand, and that's one of the things we're trying to ensure in the tender documents, are the bits that relate to systems assurance and RAMs and the certification process, and the cost element that relates to those as a control mechanism of the contractor to be doing all those sort of things. But again, packaged up into a cost-weighted elements, and those various elements will have to be measured either by looking at the amount of work that's done, or the material that's on site, or whether a specific deliverable like the design report has been issued, which is worth X many rupees, X many baht, and so that will be tracked on that basis.
What could be the escalation of cost generally as thumb rule for any particular package from the contract price?
Now, you mean escalation or increase in price due to
delays or changes, change order, change request?
Now, our design for civil works was awful. Had many discrepancies, missing items and the like, which was significantly increased the cost. We did quite a lot of value engineering to counter that. Now, they hit the contingency in the provisional sum, which is something I wouldn't have done. The provisional sum should usually be for specific items that you expect to happen, but we don't really know how much they're going to cost at this point in time. Now, the amount that they allowed for provisional sum in the civil work and the track work was both about 15%. But in this track work, there are no provisional sums, so it was effectively all contingency, and we've hardly look at the civil work, and the 15% was about 90% real provisional sum items, such as the M&E permit, and 2 stations which were only going to be built as shells, and then they decided to do a full fit out of those, and that decision hadn't been made. And so that gobbled up 90% of the provisional sum. But if all the errors and stuff had come out, I think we would have spent of the contingencies due to errors and those sort of things due to the low standard of coordinated design in Thailand. But about 15% was spent on provisional sums, which was in the budget, but did cause delays. In 2 cases, we pushed the time for those 2 stations I was talking about, 210 days, and an extension of time of 150 days for the electrical permanent works. But as it was all part of the original contract, we looked relatively sweet, and so we compare with the other projects that are running, and we're the only one that theoretically hasn't really caused any problems. But 10% is the answer to your original question, quite possibly, 5 to 10%. Due to errors, due to the odd sort of things that have to be added or taken out because of unknowns, and they tend to be utilities, moving things because it clashes with something else, But it doesn't include a major change of shifting the alignment a little bit or doing fiddly sort of things that do happen, and they could happen in Hyderabad. We all know that L&T has got issues with the alignment. I think is it around us or the assembly building or something. First of all, it's here, and then it's there, and then maybe it's back again. And that's all areas where potentially, well, not could make money, EPP concessionaire, so whether they can or not, another issue. Any more questions?
Chris, there is a question if the change request or the realignment comes after a significant amount of work has been done for various, it could be for various reasons. Who is what you call liable to make take the hit? I mean, in terms of financially, who's going to pay for that? X number of pillars, and then there is a realignment request.
Yeah. If it's something like a realignment request, it is the employer's responsibility. If it is aborted work because the client has changed his mind too late, again, it's the client that should pay. And therefore, sometimes it relates to cost, and that's more easily seen. Okay? Because you can see that something's been built, it's not needed, it has to be knocked down and rebuilt, and something else has to be built. And particularly if it's remeasurement, the contractor can get paid for it. If it's a new item that was never envisaged, there's a lot of arguing over what the cost is, and again, the contractor has to be paid. The real issue, though, sometimes is an extension of time. Because an extension of time often brings costs with it. It brings that 10% overhead cost with it. So you don't really want to have extensions of time for that, of course, the more obvious reasons for problems that might cause other contractors and the like. So you really do, in a Western environment, go right back to your program, look to see what was on the critical path, see what was done and what wasn't done, and really analyze the program and see the impact as it relates to the documents, letters that were written and the dates on those letters. And there's a whole business called claims management that is done by international contractors internationally, where that's how they make their profit out of projects. It work that way in places like Thailand, and I assume India. What happens is the contractor starts, this is a problem, blah, 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 and he keeps on and on and on about it. He then ends up talking to the contractor, to the client, and they do some sort of deal, which isn't necessarily always fully justified and is tinged with a high level of corruption. So that's how it gets sorted out in Asia, unfortunately. That answers your question.
I think in the case of Hyderabad, since the employer is not spending a substantial amount of money, the call will be with the concessionaire to decide whether the realignment is actually profitable or not.
Well, it's very tricky because in India, in Hyderabad, the chief ministers can do a lot. They can cause a lot of trouble. Like, an L&T has to manage that somehow.
Yeah.
Because they're not going to get any money from anybody because there's no money there. And that was one of the original things I said. If there's a budget and it's spent on capital projects, you can't get any more because there's nobody's got any budget for that.
Yeah.
What L&T can get benefits somewhere along the line. They can get extensions of time so they don't have to pay liquidated damages, and that covers maybe their own delays, if you know what I mean. Let's say they don't meet the operating date that they're required under the concession agreement because of their own fault.
They can.
If there's a government delay when that all gets hidden, then they're happy. They can do a deal on a land swap, and I think they did a few of those in relation to what they were going to get at the depot and not somewhere else. They can get some other benefits. They can get the rights for maybe another little bit of extension somewhere. And so L&T has to play very much a political game because it's not obvious money or time that's treated as a claim, because it is L&T's contractors claiming against them.
Yeah.
Now, in a lot of cases, L&T is the contractors themselves, and may even claim against the special purpose vehicle, the concessionaire, because it might benefit them. But then there are all the other rail systems people and things like that. They could also potentially claim. So it's a tricky business. It's a much harder business for a PPP concessionaire, but a PPP concessionaire probably has more control over some of the things that they do. But let's look at Hyderabad again. There have been a lot of cases where their progress has been delayed by the police, not giving them access to good fronts and all of that. Now, some of those have finally been resolved and L&T is able to move on, but if it was a normal project, it would be potential. But those claims are very difficult, even under a conventional contract in Asia, the way things work. In Europe or America, the contractor would have it all documented, and there'd be a stack of claim for material and Primavera printouts there to prove that this had caused delays and cost, and they would claim it all.
I think, Chris, that's it for today.
Okay, then. We were talking about another one this week, were we? Was that your intent?
Yeah, depends on your schedule.
Okay. Okay, well, I generally can do this time. The next one I would give is only about 2 hours worth of presentations that we might split. It's in relation to I've done contract management, but I finished contract management. I've got to think about it. I've got project controls I want to do, which goes into more of some of the processes that back up this sort of work for this presentation. I'd have preferred to have done that face-to-face because it's slightly more complicated. Whereas here you're just visually seeing a lot of things, but we can do that. Then I'll talk about perhaps another couple of soft areas such as stakeholder management and the like. And then I probably need to do some work with specific interface management and the processes there. But that would probably be the week after or the week after that. Okay?
I think this project control and stakeholder management could be interesting because most of these guys might be working on various projects.
Okay, well, stakeholders pretty, it's a bit theoretical, but I mean, it's, and if people are listening, that's cool. But it's a big thing internationally. It's done, it has to be done in Asia. I mean, L&T do it, but it's done at a different sort of level. So yes, that's one I could bring up, and maybe even that's the next one I do, because that's an hour session. And let me think about which ones I need to do next. Project controls is hard work, and I might prefer to be in India for that.
Okay.
Let me think about that.
We'll think about that, yeah. Okay, Chris.
Okay, thanks, guys.
Yeah.
Now, I hope you found that better than the last 2 weeks ago. Last 2 weeks ago, I felt very uncomfortable. Maybe I'm a bit more relaxed just talking at a computer screen. I'm not sure. So we'll have to see how we go. But if you're not getting good value out of it, please tell Binoy, and we'll try and see what we can do. Okay?
Sure. Okay, Chris.
Okay, thank you.
Thanks.
Bye-bye.
Thank you. Bye.